Hello everyone, you are welcome to another video session of Python for All. In this video, we will talk about enclosing functions. Just like in our last video, we started by discussing functions and we looked at the different types of functions in Python. But today, we will talk about enclosing functions. In Python, an enclosing function is a function that is defined inside another function. The inner function has access to the variables and names that are defined in the enclosing functions. This is also known as lexical scoping. For example, the following code defines an outer function and an inner function. Let's look at the code snippet. Here I have def, outer function, no parameter, and then the docstring. This is the outer function. And right inside the function body, I define x is assigned to 10 is assigned to x. In other words, x is equal to 10. Then I move to the next two lines below and define an inner function also that takes no parameter, and then go with the docstring. This is the inner function. And right inside the inner function, I print x. So mind you, in both function, I do not have any return statement. So right outside the inner function, but still inside the body of the outer function, I call the inner function. Okay. Then outside the outer function, now I call the outer function. If I run this cell, I have this function already in my namespace. Okay, so you can see that when I run this cell, it prints what 10. In other words, the inner function is called, okay, right inside the outer function, and it prints 10. And what is actually the value of x? 10. So this is just an example of enclosing functions. Okay, now enclosing functions are a powerful tool in Python. They can be used to create helper functions, closures, and decorators. We're going to see decorators, closures, and helper functions subsequently in our videos. But what helper function talks about here is that if you need a function, for instance, that is just aiding your main function. For example, you saw in the Fibonacci function we wrote in the previous video that I had another helper function called fib sequence that calls the Fibonacci function. I can actually have this fib sequence as an inner function in Fibonacci function. Then I'll call it just fib sequence, and I embed it right inside the Fibonacci function, so that when I call the Fibonacci of any number, what it does is to print, it returns the print or the sequence, the full sequence, not just the number at that index. So that's another way of using these closing functions, okay, by utilizing them to create helper functions. There are some benefits of using enclosing functions. One of them is encapsulation. Enclosing functions can help to encapsulate data and functionality. This makes the code more readable and maintainable. The next is reusability. Enclosing functions can be used to create reusable helper functions. This can save time and effort when writing code. The next is extensibility. Enclosing functions can be used to create extensible code. This makes it easy to add new features to the code without having to break or make any major changes. So what it does is that the enclosing function makes us, gives us that advantage of being able to extend our code without breaking the code or without having to make any major change to our code when we want to add new features to the code. We will see all of this in our practical sections. The next I want to talk about is positional and keyword arguments. When we looked at functions, we said a function, starts with the def keyword followed by the function name and the parameters. The parameters are actually what the input arguments. Now let's see that in the types of argument that we can have when defining functions. The first of them is positional arguments. And these are arguments that are passed to a function in the order that they are defined. In other words, by their position. The order of the positional argument matters. In other words, the order is very important. If the position is altered, then you expect your code to break. In other words, because the function will use the argument in the order that they are received. The second one is the keyword arguments. The keyword arguments are arguments that are passed to a function with a keyword. The keyword is the name of the argument. In some cases, we call them named arguments. Okay, is the name of the argument, and the value is the value of the argument. The order of the keyword argument does not matter. The order is not important. But for positional argument, the order is very important. Let's look at this example. Here we have dev some function. It takes argument 1, argument 2, keyword argument 1 with default value of 2.0, keyword argument 2 with default value of true. Then right inside the function block, I print argument 1, argument 2, keyword argument 1, and keyword argument 2. Now, let's move in right here and show that example. It's quite lengthy, but I would try to extend it. So here I have same, and I say print. I'm using an X string now. So I will simply say print F string. Okay, let me remove the F string to make things clearer. So just simply to make things shorter, simply print what the example I have there, print argument 1, print argument 2, okay, and then print keyword argument 1, and print keyword argument 2. Yes, remove this. This is what I have. So I'll run this function. I have it in my namespace. Now I want to call the sum function passing hello and then 1 and 4. 1 and 4 is a list of 1 and 4, a list of an element having list having an element 1 and 4. If I run this, what do we have? Because the keyword argument 1 and 2 are default 2.0 and true, they are keyword argument. Okay, you can see it prints 2.0 and true. And then you see it takes the position of arg1 and arg2 doesn't matter. So you can see it prints hello and then 1 and 4 and that. Now in this case, you notice that it prints hello and then followed by the list of 1 and 4. Now let's do something here now. Let's execute some function hello 1 and the list of 1 and 4, and then the keyword argument 1. Let's change it to assign a value of 3.0 to it. If I run this cell, what do I have? It prints hello. You see, maintains the position of argument 1, argument 2. In this time, keyword argument 1 is now 3.0 because I've changed the value, but the last keyword argument is still true. Okay, now let's also try the next one, passing in argument hello, the list, keyword argument, then and keyword argument 2. Let's see what we have. If I run that, it prints same hello, the list of 1 and 4, 4.0, and high. You can see in the position argument 1 and 2, position is important. The sequence of the keyword arguments does not matter in the call. In other words, I can change the position of the keyword argument. It doesn't matter. Let's see with this example here. Call the same sum function. You can see here, I've passed keyword argument 2. I started with it first as hello, argument 1 as high, keyword argument 1 as 6, and argument 2 as a list of 1 and 4. Okay, I ended it with a comma. You can end with a comma, you can still remove the comma, it doesn't matter. If you run that, what do we have? You see it prints what? High, argument 1. It takes that's the position of argument 1, followed by argument 2, then followed by keyword 1 and but you can see that already in when calling the function, the position of the keyword argument doesn't really matter where we place them. The same way with the argument 1 and argument 2. Now, let's move to another function. Same define same function. In this case, we have arg1, keyword arg1 equals 2.0 and argument 2. Then let's print argument 1, argument 2, and keyword argument 1. If I run this function, see, Python throws up an error. And what does that tell us? It tells us syntax error. Non-default argument follows default argument. What it means is that when we pass in a default argument here as a keyword argument, okay, we are supposed to continue that with default argument. You cannot pass a non-default argument after a default argument in Python. No. But there is a way around it. How do we do it? We introduce this asterisk. What this does is that it tells Python that after this asterisk, you are allowed to pass a position argument after a keyword argument or a named argument, which is a default argument in Python. If I run this cell now, what do I have? It takes it. Now, let me call some function 1 and argument 2 equals 20. If I call this, run this cell, what does it do? Is it prints what? 1, which is argument 1. It prints 20, which is argument 2, but the keyword argument 2 is default 2.0. It prints it. So you see, it retains that position. You can as well pass the same input like this 123. Let's pass it and see what we have. If I pass it this way, Python throws up another error. And what does the error say? It tells you that you are passing position arguments, but rather the sum function takes 1 to 2 position arguments, but 3 were given. 3 position arguments were given. So the position is important. So you're supposed to, it takes only 2 position arguments and 1 keyword argument. So it will throw up this error. So what you need to do is to call the function 120 and pass in, you know, and specify the keyword arguments. Okay. Now again, let me repeat by passing argument 1, argument 2, and the key. This time I pass argument 1 and passing 20 as the keyword argument and passing argument 2 as 3. If I run this again, what do you see? It's printed because this asterisk after this false this keyword argument allows argument 2 to be passed as a named argument or a keyword argument, and that's why it prints argument 1 and prints argument 2 following, which is 3, followed by what? 20, where in this case the 20 now is what? Your keyword argument. Oftentimes in Python, let me give an example. Let's say I have a function f of x, okay, a function that takes x and y like this, or let's say a function that takes a and b, and then I should return the sum of and a and b, right? If I have this function here and I run it, oftentimes in Python, it's often advisable to call, in this case, normally I can call it as f of 1 and 2. So right, I can say print f of 1 and 2, print f of 1 and 2, which is perfectly correct. But it's always advisable to use, use the named argument. So I'll say a is equal to 1, b is equal to 2. In the same way, I can come here and call it, start with b is equal to 2 and a is equal to 1. If I run this, what do I have? It gives me the same result. If I likewise come here and say a is equals 1 and b equals 2, I run it again, run the same cell, what do I have? I have same result. So it's always, it is readable to pass in your position arguments this way explicitly. It is more readable. So lastly, we'll look at here another function example which says add numbers. I have x, y, z, and I have given a default value for z. So z is a default is a position argument or a named argument with a default value of 10. In my next video, I would actually give another detailed example between position arguments and keyword arguments, and take more example of that and give more elaborate uh, example to illustrate that, so that you have a better understanding of how to use it and when to use it. So here we're adding there's not two numbers, actually adding three numbers. Okay, add 1 second. I go back here, add three numbers, right? And return x plus y plus z. So if I run this, what do I have? And this time around, I want to print add numbers 10, 20, and 50. If I run it, what do I have? It gives me 80. Okay, I can as well call this print, gives me 80. But it is more readable to call add numbers, and I'll say x equals 10, y equals 20. And if I omit z, because I've given a default value for z, it runs and gives me what? 40, because the default value of z is 10. Or I can likewise come here and say z equals 10. If I run this again, 40. If I alternate the position, I say start with z equals 10, y equals this, and x equals 10. If I run this cell again, it returns the same value. So the position now, when it is named, doesn't really matter, because Python understands when you name it, it understands which variable or which input is which. So in our next video, we'll talk more about uh, position arguments with the examples and keyword, especially keyword arguments. There we'll see how we can pass in dictionaries as keyword arguments in functions. With this, we have come to the end of this video. I will leave a link for the download of this notebook if you require it in the description section. And I would like you to share this video. Please like it. If you have any question, please do not hesitate to leave it in the comment section. Subscribe to my channel if you have not done so, and do not forget to click the notification bell to get notified of my new uploads. Until then, see you in my next video. Bye.